describe the solution to that puzzle, but those of you who want to try to still solve it, feel free to write down your solution for the most efficient highway network between 4 cities that are at all the corners of a square. So what highway system would you use if you were charged with doing it for the least amount of money, and your highway system, the cost is proportional to the linear length of the highway itself? So back to questions of string theory and cosmology and unified theories.
But one thing before we get to that one relates to puzzle.
Yep.
I'm going to give you another puzzle as well, but this puzzle I'm going to give the solution to.
Okay.
So it's not part of that one, but I think it's interesting because it also illustrates a point about what does puzzle have to do with physics.
Yeah.
In a simple way. So this is the puzzle. Can something be falling and not hitting the ground? That's the puzzle. What is falling? What could be falling and not hitting the ground ever?
Yeah.
Now, this sounds like...
Are you asking me that question? Or?
No. I'm sure you can say it immediately, but this is a puzzle. This is a puzzle that you would think, okay, something is falling and it's not hitting the ground. What could it be? What does it mean?
Yeah.
And so this sounds like, it can be some kind of a word puzzle. It's not. It's an actual puzzle. And it's a puzzle that Newton solved. Newton solved in the following way. So this is a question that we could raise, is that there's a moon, and first of all the question is, why isn't the moon falling? And the second question is that, okay, if it's falling, then why is it not hitting the earth? So those were the questions. Those were the questions. And the answer that Newton gave was so elegant, which is the solution to this puzzle, so Newton should get the prize for that, is that no, actually, moon is falling, but it just avoids hitting the earth. Now, how does that work? And this is beautifully illustrated in this book, Principia Mathematica, which shows that if there's no earth, if you get rid of the earth, and if you look at the moon, and if the moon is moving in some direction, it will continue going straight. But if you have an earth, instead of going straight, if you have anything going straight, if you have, like, for example, a cannonball shooting going straight, if you have an earth, it will fall on it. So if you have an earth, and if you have a cannonball shooting from it, it will fall somewhere on the earth. If you shoot a cannonball with a higher speed, it will go farther down and farther and farther. It can go from the North Pole, let's say, all the way up to the South Pole of the earth if you give it enough kick. But if you really give it a huge kick, it will go all the way around and it will continue going around. So what's happening is that ball is falling down, because if it wasn't before the earth, it would go straight. So having the earth causes that cannonball to try to hit the ground. It's falling. Namely, instead of going straight, it's falling. Just going not straight, falling towards the earth. But since the earth is round, it keeps on missing hitting the earth. So the cannonball or the moon itself is the answer to the puzzle. That is falling. If it wasn't for the earth, it would go straight. So it is falling, but it's not hitting the earth because the earth is round. It's like a game between the roundness of this earth and this falling of this moon. So this is an example where the puzzle and the poetry and physics all melt together. And of course, they can be beautifully explained by mathematical formula that Newton discovered, but the whole thing is a simple-looking puzzle that it kind of illustrates the basic link between physics and puzzle.
Yeah, it's a beautiful example, and it's perhaps worth noting that there was a period of time when you and I and a few other of our friends would find ourselves at the same Christmas party every year, and Tracy and my wife, your wife, would all leave us because we'd all start to talk about these puzzles in one little corner of the room, but they're off, drinking and partying and having a good time. And the one that you told me, one Christmas party, that was the following. I'll just ask it to the audience, and again, it's one that people try to solve, which is you have a picture, and you want to hang the picture, but you're going to hang the picture from 2 nails, not from 1 nail, such that it's completely stable if both nails are secured to the wall, but if you remove 1 nail or the other and you just leave the other in the wall, the picture will fall. And for those of you who are more mathematically inclined, this puzzle gives you insight into a subject of mathematics called homotopy, and it has to do with non-abelian homotopy groups and the non-abelian nature of the homotopy group of the plane punctured at 2 points. So for those of you who speak mathematical language, that's what this is about. So again, the puzzle that Kurman gave is a beautiful one that puts the poetry of physics and motion in the universe together. And here's one again, that Herman gave me, that I went home. After that party, we got home at like 2 o'clock in the morning. At 6 o'clock in the morning, I was up, and my little daughter, who was like 5 at the time, we did it. We took a picture, we put it up, and yeah, and you know,
I remember getting that picture. Yes, absolutely.
yeah, exactly. So
You gave me some good puzzles. In fact, some of them in my book about the glasses and the symmetry breaking, which is part of that book. So yes, we have had good fun with puzzles and the relation between physics and.
absolutely. So I want to turn to one other thing that's in your book, which was quite unusual, and for me quite inspiring, which is you have a section on science and religion. And you know, it's interesting. You know, at the World Science Festival, which is what this program is part of, on various occasions we've had programs on science and religion, and we do them because we find it a fascinating conversation between various distinct ways of looking at the world. We also have conversations between artists and scientists, artists and theologians and philosophers. So we like science to reach out to the world more broadly. But I have to tell you, there were a number of scientists who came back at us really hard, really angry, that we were having a program on science and religion at the World Science Festival. They said, what in the world does religion have any role there? And basically our answer, and you know, Tracy Day, you know, who's the co-founder with me at the festival, our view was, what are you afraid of? I mean, any conversation that's rich, that allows scientific ideas to be in dialogue with other qualities and perspectives on the world is a good thing. It's not something to shun, but nevertheless there can be a recoiling. And so were you concerned about having science and religion? Like what led you to include that section in your book?
Well, I think that religion and science have many commonalities. So I think that the deeper truth is what one is after. And so of course, as described in the book, I think there are ultimately different realms of experience, religious experience and scientific experience, and I kind of describe them in different ways. And I wanted to share that, you know, scientists are also have views on this, and I gave examples.